Let's next talk about Orsat analyses. What happens is you'll run a furnace and you bring in fuel, you bring in air, you have designed this using finite element analysis, very fancy techniques to guarantee that you are going to have excellent combustion properties. But over time, things change. Maybe a little hole on the fuel injector gets plugged, and so you're not getting quite the pattern that you had before. And so therefore you're going to want to measure not only what's going into this furnace, but you also want to measure the products, the flue gas, the exit gas out of the furnace or this combustion chamber. So to measure that, the device that was first developed is an Orsat analyzer, and variations of this are still used today. But an Orsat analyzer, old school form, you would bring in a bottle of your flue gas, you'd capture it in a bottle, and then you would allow it to pass through some various kinds of absorption columns, okay? But they were aqueous or water-based solutions of different chemicals that would absorb maybe carbon dioxide, carbon monoxide, nitrogen, etc. And so I would know what was going on based on the number of different kinds of reagents that I used. I could analyze anything except for water because these were water-based solutions. So I ended up not knowing how much water I had, but I had a great analysis of the gas on a water-free or a dry basis. And so when you hear someone talk about an Orsat analysis, it is analyzing a gas without the water. So we'll use this in various ways, and I'm going to guess that many of you can see that we will soon be adding this in with our knowledge of psychrometrics so that I could come back to the water basis. But let's just see if we can make sense of what an Orsat analysis means. Now we're going to do one quick little example. We're going to look at one where I know what the flue gas actually contains and get the Orsat analysis out of this. This is the simplest type of example. So this little sample, I have 30 mole percent water, 20 mole percent CO2, 50 mole percent nitrogen. So what will the Orsat analysis tell me? Well, it's easiest if I assume a basis. So if I say I have 100 moles of the flue gas, that's probably not correct, but it's okay because I'm going to eventually be turning it back into a percent or a fraction. So if there are 100 moles of flue gas, then I have 30 moles of water, 20 moles of CO2, and 50 moles of nitrogen. So on a dry basis, I have 70 moles of gas. So that means that the Orsat analysis will tell me that there are 2/7 CO2 and 5/7 N2. So this is pretty simple. Sadly, to go the other direction requires just a little bit more work, and we'll do that in the next lesson.